Humans have always gazed at the sky, they have always dreamed of flight, to soar above the clouds, to see the world from above. This dream seemed impossible for so long, it was the stuff of myths and legends. Then, slowly, ingenuity turned fantasy into reality. Brave pioneers built fragile machines. They risked everything for a few moments in the air. Their courage paved the way for a revolution. The sky was no longer a barrier. Today, flight is commonplace. Giant metal birds carry millions. They cross oceans and continents with ease. The world has shrunk. Distant lands are now just hours away. Business, leisure, family connections, all rely on this marvel. Aviation is a testament to human ambition. It is a symbol of progress. It connects us in ways previously unimaginable. Yet this incredible achievement is not without its shadows. It carries an inherent risk. The realm of flight is demanding. It is an environment alien to human beings. We operate thousands of feet above the earth. Here the air is thin. The temperatures are extreme. Gravity is a constant, unforgiving force. Aircraft are complex systems. Thousands of parts must work in perfect harmony. Pilots undergo rigorous training. Engineers design with meticulous care. Safety protocols are constantly refined. All this effort aims for one goal: safety. Despite all precautions, the unexpected can happen. The sky can turn from a pathway to a peril. A routine journey can become a fight for survival. The forces involved in aviation are immense. When things go wrong, they can go wrong catastrophically. The line between a normal flight and a disaster can be very thin. Understanding this duality is crucial. It helps us appreciate both the wonder of flight and the continuous quest to make it safer. This quest is never ending. Aviation accidents are statistically rare. Flying remains one of the safest forms of travel. Yet when an aircraft crashes, the impact is devastating. The human cost is immeasurable. The immediate aftermath is filled with questions. The search for truth begins amidst the wreckage. The flight recorders, the so-called black boxes, are vital. The goal is not simply to assign blame. Each accident provides lessons. They help prevent future tragedies. Some aviation accidents etch themselves into history. Flight 708 is one such incident. Its story is a stark narrative of a journey that went terribly wrong. It highlights the complexities of modern aviation and underscores the tireless efforts to ensure safety. We must look closely at what happened. Flight 708 had disappeared from radar screens. Contact was lost. Concern grew into a widespread search operation. Finally, the grim reality emerged. The aircraft was gone. Its legacy is etched in the ongoing pursuit of air safety. Flight 708 was operated by a Meridian Airlines Boeing 737-400. This aircraft model was a popular choice for airlines worldwide. It was known for its reliability and efficiency on short to medium haul routes. The Boeing 737 series had become one of the most successful commercial jets ever built. Millions of passengers had flown safely on these planes for decades. Airlines appreciated its robust design and its ability to operate from a wide range of airports. It was considered a proven and trusted machine in the demanding world of commercial aviation. Its familiarity bred a sense of confidence among both crews and the traveling public. The specific aircraft assigned to Flight 708 carried the registration HALMP. It had been delivered to Meridian Airlines 12 years prior. This was a moderate age for a commercial jetliner. Its maintenance records were scrutinized intensely after the incident. They showed a history of regular checks and scheduled servicing, all performed in accordance with industry standards. No major recurring technical issues were immediately apparent in its logbooks before its final flight. It had accumulated approximately 32,000 flight hours and over 15,000 flight cycles. Each cycle represented a takeoff and a landing, the most demanding phases for an airframe. The Boeing 737-400 was equipped with two powerful CFM56 turbofan engines. These engines were also widely used and had a strong safety record. The cockpit featured a mix of traditional analog instruments and some newer digital displays, typical for aircraft of its generation. It was equipped with standard navigation and communication systems. It also had weather radar, crucial for detecting adverse conditions. Importantly, like all commercial airliners, it carried a cockpit voice recorder, CVR, and a flight data recorder, FDR. These devices would later prove indispensable to the investigation, holding the silent testimony of the aircraft's final moments. This particular model of the 737 was designed to carry around 150 passengers. It was well suited for the kind of regional routes Meridian Airlines specialized in. Pilots generally found the 737-400 to be a responsive and stable aircraft to fly. Its performance characteristics were well understood. It could operate effectively in various weather conditions, though, like any aircraft, it had its limits. For the crew of Flight 708, stepping onto HALMP would have felt like any other day at the office. It was a familiar environment, a machine they knew well, ready for another routine assignment across the skies. Flight 708 was scheduled to depart from the bustling Capital City International Airport. Its destination was Port Royal, a popular coastal city. The flight was designated MA 708 by Meridian Airlines. This route was a regular service for the airline. It connected a major economic hub with a significant tourist and commercial center. Many passengers on board were likely business travelers or families heading for a vacation. The flight was expected to take approximately 2 hours and 30 minutes. This was a common duration for domestic or short international flights. The airline had operated this route for many years. The planned flight path would take Flight 708 predominantly overland. It would climb to a cruising altitude of around 33,000 feet. This altitude is typical for commercial jets, allowing for fuel efficiency and smoother air above most weather systems. The route passed over varied terrain. This included flat plains, rolling hills, and some mountainous regions closer to the coast. Air traffic controllers along the way would monitor its progress. They would provide instructions and ensure safe separation from other aircraft. For the pilots, navigating this route would involve standard procedures. They would rely on pre-programmed flight management systems and radio beacons. This journey between Capital City and Port Royal was a daily occurrence for Meridian Airlines. They often operated multiple flights on this sector each day. The predictability of the route usually meant straightforward operations. Pilots became very familiar with the landmarks, the communication frequencies, and the typical weather patterns. While no flight is ever truly routine in the eyes of aviation professionals, this came close. The sheer volume of successful flights completed on this very path underscored the general safety and reliability of the operation. It was a corridor in the sky, traversed countless times without incident. Flight 708 was scheduled for an early evening departure, around 6:30 p.m. local time. This meant that much of the flight would take place during the hours of darkness. Night flying presents its own set of operational considerations. Pilots rely more heavily on their instruments. Visual cues from the ground are limited, however modern aircraft are perfectly capable of safe night operations. The crew would have been well trained for these conditions. The transition from dusk into full night was an expected part of this particular flight schedule. For the passengers, it might mean settling in for a quiet journey. Flight 708 was scheduled to depart from Capital City International Airport. Its destination was Port Royal, a popular coastal city. The flight was designated MA 708 by Meridian Airlines. This route was a regular service for the airline. It connected a major economic hub with a significant tourist and commercial center. Many passengers on board were likely business travelers or families heading for a vacation. The flight was expected to take approximately 2 hours and 30 minutes. This was a common duration for domestic or short international flights. The airline had operated this route for many years. The planned flight path would take Flight 708 predominantly overland. It would climb to a cruising altitude of around 33,000 feet. This altitude is typical for commercial jets, allowing for fuel efficiency and smoother air above most weather systems. The route passed over varied terrain. This included flat plains, rolling hills, and some mountainous regions closer to the coast. Air traffic controllers along the way would monitor its progress. They would provide instructions and ensure safe separation from other aircraft. For the pilots, navigating this route would involve standard procedures. They would rely on pre-programmed flight management systems and radio beacons. This journey between Capital City and Port Royal was a daily occurrence for Meridian Airlines. They often operated multiple flights on this sector each day. The predictability of the route usually meant straightforward operations. Pilots became very familiar with the landmarks, the communication frequencies, and the typical weather patterns. While no flight is ever truly routine in the eyes of aviation professionals, this came close. The sheer volume of successful flights completed on this very path underscored the general safety and reliability of the operation. It was a corridor in the sky, traversed countless times without incident. Flight 708 was scheduled for an early evening departure around 6:30 p.m. local time. This meant that much of the flight would take place during the hours of darkness. Night flying presents its own set of operational considerations. Pilots rely more heavily on their instruments. Visual cues from the ground are limited, however, modern aircraft are perfectly capable of safe night operations. The crew would have been well trained for these conditions. The transition from dusk into full night was an expected part of this particular flight schedule. For the passengers, it might The cockpit of Flight 708 was commanded by Captain Edward Jensen. He was a seasoned aviator with over 14,000 flight hours. Assisting him was First Officer Michael Davies, with 5,500 hours. Both were well regarded and fully qualified. The cabin crew consisted of 4 flight attendants. They ensured passenger safety and comfort. The entire crew appeared fit and ready. Teamwork and communication were vital. Good crew resource management is key to safety. The men in charge seemed well prepared. The pre-flight preparations for Flight 708 were thorough. Captain Jensen and First Officer Davies meticulously worked through their checklists. They ensured every system on the Boeing 737-400 was functioning correctly. Passengers boarded, finding their seats, a sense of anticipation in the air. The cabin doors were secured. The ground crew disconnected the external power and air conditioning. With a gentle pushback from the gate, JLMP began its journey. The powerful CFM56 engine spooled up with a familiar whine, soon settling into a steady rumble. The aircraft felt alive, ready for its task. On the taxiways of Capital City International Airport, Flight 708 moved with ponderous grace. It joined a queue of other aircraft, each awaiting their turn to take to the skies. The cockpit chatter was professional, focused on the procedures. Captain Jensen received clearance from the control tower. He taxied the aircraft onto the active runway. He aligned it with the center line. Meridian 708, cleared for takeoff, came the instruction from air traffic control. First Officer Davies read back the clearance. Captain Jensen advanced the thrust levers. The engines responded with a surge of immense power. The Boeing 737-400 accelerated rapidly down the runway. The lights lining the tarmac blurred into streaks. Inside, passengers felt the firm pressure pushing them back into their seats. At the calculated rotation speed, Captain Jensen gently pulled back on the control column. The nose wheel lifted, followed seconds later by the main landing gear. Flight 708 was airborne. It climbed gracefully into the darkening twilight sky. "Positive rate," called out First Officer Davies. "Gear up," commanded Captain Jensen. The thud of the landing gear retracting into the fuselage was a reassuring sound. As the aircraft gained altitude, the flaps were progressively retracted. Flight 708 was handed over from the tower controller to departure control. The pilots acknowledged the new frequency. They followed the standard instrument departure route meticulously. This route guided them safely away from the airport and other air traffic. Below, the lights of Capital City began to shrink. The aircraft continued its steady ascent towards its planned cruising altitude. Everything was proceeding exactly as expected. There was no hint, no premonition of the difficulties that lay ahead on this ordinary evening flight. Flight 708 reached its designated cruising altitude of 33,000 feet. The aircraft leveled off smoothly. The seatbelt sign was switched off. In the cabin, flight attendants began their service, moving down the aisle with trolleys, offering drinks and snacks. Passengers started to relax. Some read books, others watched movies on personal devices, or gazed out at the darkening sky. The hum of the engines provided a constant, reassuring backdrop. Captain Jensen and First Officer Davies monitored the flight instruments and systems. The journey progressed without incident for well over an hour. Flight 708 was a small beacon of light traversing the vast dark expanse. The weather was generally clear, with only scattered clouds reported further along the flight path. For everyone on board, it was just another flight, uneventful and proceeding as planned. The destination, Port Royal, was drawing steadily closer. Then, a subtle change occurred. Perhaps it was a slight, almost imperceptible vibration, or maybe a flicker of an advisory light on one of the many instrument panels. It was something small enough to be initially overlooked or quickly dismissed. However, the anomaly did not disappear. The crew's conversation would have shifted from casual monitoring to active diagnosis. The situation took a serious turn. A system malfunction became apparent. A red warning light illuminated. An audible alert sounded. Captain Jensen and First Officer Davies recognized the issue. Their focus narrowed on the problem. They executed emergency procedures. Checklists are critical tools. They guide crews through failures. The atmosphere became tense. Communication was concise. They informed air traffic control. The aircraft responded to the trouble. It struggled to maintain altitude. The autopilot might have disengaged. The crew took manual control. They actively flew the aircraft. Captain Jensen declared an emergency. The struggle for control became desperate. The aircraft was no longer responding. A critical system had failed. The Boeing 737 entered a steep descent. Warning horns blared in the cockpit. Final communications were urgent. Controllers tried to assist. They cleared traffic and prepared emergency services. Communications ceased. The crew focused on flying. The descent was swift. Flight 708 appeared as a falling light. Inside, forces were extreme. Passengers knew something was wrong. The aircraft disappeared from radar. One moment it was there. The next, it was gone. The impact was devastating. Modern aircraft are marvels of complex engineering. They rely on intricate networks of electrical and electronic systems. These systems control everything from navigation to flight surfaces. When these systems function correctly, flight is smooth and predictable. However, a failure within these critical pathways can be insidious. It can start as a minor glitch, a mere whisper in the wires. This initial fault might present confusing signals to the flight crew. It could make the aircraft behave in unexpected ways. Consider the aircraft's flight control system. In many modern jets, pilot inputs are translated into movement of control surfaces by sophisticated computers and actuators. If a sensor provides incorrect data or if a computer malfunctions, the consequences can be severe. The aircraft might not respond as the pilot's command. It could pitch or roll unexpectedly. The crew would then face a difficult battle. They must first identify the source of the problem, then they must try to override or compensate for the faulty system. Another area of concern involves the auto-flight systems. This includes the autopilot and auto-throttle. These systems are designed to reduce pilot workload and enhance precision. However, if they receive erroneous information from failing sensors, they can lead the aircraft astray. Beyond the complex electronics, the raw mechanical aspects of an aircraft are equally critical. The engines are the heart of the machine, providing the essential thrust. An engine failure, while rare, is a serious event. Most twin-engine aircraft, like the Boeing 737-400, are designed to fly safely on one engine. However, the nature of the failure matters greatly. An uncontained engine failure is particularly dangerous. This is when parts of the rapidly spinning engine break off. These parts can be ejected at high velocity, like shrapnel. Such debris can damage other parts of the aircraft. It can sever fuel lines or hydraulic lines. It can strike the fuselage or the wing. It can even damage the remaining operational engine. This scenario dramatically escalates the emergency. The pilots would not only be dealing with the loss of one engine, they would be fighting a crippled aircraft with multiple secondary failures. Fire is also a significant risk following a severe engine failure. The crew would need to execute fire suppression procedures rapidly. Their training prepares them for this, but it's a dire situation. The flight crew are the final guardians of safety. Their training is extensive, their skills honed over years, yet they are human. In the face of a sudden, complex emergency, the pressure is almost unimaginable. Alarms blare, lights flash, and the aircraft might be behaving erratically. The first challenge is to correctly diagnose the problem. Modern aircraft have numerous interconnected systems. A failure in one area can produce warnings that seem to point elsewhere. Misidentification of the true nature of the malfunction can lead to incorrect actions. This can worsen the situation. Crew Resource Management, or CRM, is a cornerstone of aviation safety. It emphasizes effective communication, teamwork, and decision-making in the cockpit. Ideally, the captain and first officer work together seamlessly. They cross-check actions and challenge assumptions respectfully. However, under extreme stress, CRM can break down. One pilot might become fixated on a particular diagnosis. The other might hesitate to voice concerns. The startle effect, the initial moments of shock when something goes catastrophically wrong, can temporarily impair cognitive function. Recovering from this requires immense mental discipline. The design of cockpit interfaces and checklists is also a factor. Aviation accidents are seldom the result of a single isolated cause. More often, they are the tragic culmination of a chain of events. Several contributing factors, often minor in themselves, can align in an unfortunate sequence. This is sometimes described using the Swiss cheese model. Imagine several slices of Swiss cheese, each with holes in different places. If by chance all the holes line up, a hazard can pass straight through, leading to an accident. These holes can be active failures or latent conditions within the system. An active failure is an obvious error or malfunction. For example, an engine failing or a pilot making an incorrect input. Latent conditions are hidden weaknesses. These might include flaws in training procedures, maintenance oversights, or even shortcomings in organizational safety culture. These latent conditions can lie dormant for a long time. They only become apparent when an active failure occurs. The investigation into Flight 708 would aim to identify both the active failures and any underlying latent conditions that played a part. This approach offers deeper insights for future prevention. It is possible that Flight 708 experienced an initial technical problem. This problem might have been manageable on its own. However, perhaps this initial fault then triggered a secondary, unexpected failure. Or maybe an environmental factor like unforeseen weather complicated the crew's response. The human response to the initial problem could also inadvertently create a new problem. Aviation accidents are seldom the result of a single cause. They are often the tragic culmination of a chain of events. Several minor factors can align in an unfortunate sequence. This is described using the Swiss cheese model. Imagine several slices of Swiss cheese, each with holes. If all the holes line up, a hazard can pass through, leading to an accident. Section 1. The echoes from the wreckage. The news confirmed the worst fears. Flight 708 had crashed. Search teams were dispatched immediately. They faced a daunting task. The wreckage was located in a remote mountainous region. Access was incredibly difficult, hampering early efforts. The recovery of the flight recorders, the black boxes, was a top priority. These devices held the key to understanding the aircraft's final moments. Throughout this grim process, the human element was ever present. There was immense pressure on the investigation team to conduct a thorough and impartial inquiry. Section 2. Voices and data. Piecing together the truth. In a specialized laboratory, experts began the delicate task of accessing the cockpit voice recorder. The recording captured every sound from the cockpit during the flight's final critical phase. This included the pilots' conversations, their interactions with air traffic control, and any audible warnings or noises within the cockpit. Listening to these recordings was a somber experience for the investigators. They heard the crew's voices, their initial awareness of a problem, their attempts to diagnose it, and their escalating struggle. Every word, every pause, every inflection was carefully analyzed for insight into their understanding. Simultaneously, the flight data recorder was yielding its secrets. This device had recorded hundreds of parameters. It tracked the aircraft's speed, altitude, heading, engine performance, and the position of flight controls. Technicians carefully downloaded and plotted this vast stream of data. It provided a precise, second-by-second timeline of the aircraft's behavior. This objective data was crucial for reconstructing the sequence of events. It showed exactly what the aircraft was doing, regardless of what the crew might have perceived or reported. The digital trail was undeniable. The true power of the investigation came from combining these data sources. The cockpit voice recorder provided the human context, while the flight data recorder provided the mechanical facts. Wreckage analysis added another layer. Metallurgists examined fractured components for signs of fatigue or overload. Systems specialists traced hydraulic and electrical lines. Test pilots and engineers used flight simulators to recreate the conditions faced by Flight 708's crew. They tested various failure scenarios to see if they matched the data recovered. This multidisciplinary approach was essential for a comprehensive understanding. Slowly, a clearer picture of the tragedy began to emerge. The investigation team meticulously ruled out certain possibilities. Sabotage or a deliberate act was quickly discounted based on the evidence. Severe weather, while present in the broader region, was not found to be the primary cause of the initial upset. The focus started to narrow. The data pointed towards a complex interplay of factors, likely beginning with a specific system malfunction. The investigators were on the path to understanding the chain of events that doomed Flight 708. After months of exhaustive work, the official investigation report was released. It detailed the sequence of events, from departure to the tragic end. The probable cause was a critical sensor failure. This led to erroneous data and incorrect actions by the autoflight system. The oversight in maintenance records was a key finding. The report provided closure and learning for families. Safety recommendations were issued to Meridian Airlines and Boeing. The tragic loss of Flight 708 led to global aviation safety improvements. The investigation into Flight 708 sent shockwaves through the aviation industry. The failure of a single sensor initiated a catastrophic chain of events. Existing redundancies were not always foolproof. The reliance on individual components for vital flight data was questioned. Aircraft revealed a hidden weakness. This demanded a swift response from manufacturers and regulators. New design philosophies were urgently needed. Maintenance procedures became a crucial focus. Enhanced diagnostic tools and predictive maintenance were adopted. Manufacturers developed more sophisticated built-in test equipment. Automated systems interaction with pilots during emergencies was redesigned. Software logic was programmed to be more resilient. New algorithms enabled flight computers to cross-reference information. Software updates enhanced this digital shield.
I don't ever slow up, no I don't take sh**. I got no love for the fakeness.
Section 2. Strengthening human performance, the pilot and the system. The tragedy of Flight 708 showed the limits of traditional emergency training. Pilots needed training for complex, cascading failures. Flight simulators became essential for this advanced instruction. Scenarios included unexpected elements, mirroring real crises. The goal was to build cognitive resilience and manage unforeseen events. Crew resource management, or CRM, was emphasized. Clear communication and assertiveness were crucial. Simplified emergency procedures were designed to reduce cognitive workload. Training focused on mitigating the startle effect and managing cognitive resources. Pilots learned to combat tunnel vision and maintain situational awareness. Mental fortitude was recognized as vital for survival. Section 3. A legacy of safety, broader impacts on aviation. The lessons from Flight 708 led to significant changes in aviation safety. Authorities like the FAA and ESA issued binding airworthiness directives. These directives mandated changes to aircraft design and maintenance. Airlines and manufacturers worldwide had to comply. This ensured consistent safety improvements globally. The accident highlighted the importance of transparency and data sharing. The aviation community became more committed to sharing safety information. This collaborative approach helps identify risks before they lead to tragedies. The legacy of Flight 708 is a safer future for air travel. Section 1. The unending vigil, aviation's dedication to safety. The dream of flight is a powerful one. It has connected our world in remarkable ways. Yet this dream carries an inherent risk. The skies are a demanding environment. Operating complex machines at high altitudes requires constant vigilance. Aviation is a delicate balance of technology and human skill. Learning from every single incident, no matter how minor, is absolutely essential. This relentless pursuit of knowledge has become the bedrock of the entire industry. Safety is not a final destination to be reached. It is instead a continuous, unending journey. The vast sky above us demands our unwavering respect and utmost care. Aviation accidents, like the tragic story of Flight 708, are profound losses. They bring unimaginable grief to many. However, these terrible events are never entirely in vain. They serve as critical, if painful, turning points for the industry. Such incidents force a comprehensive re-evaluation of everything previously understood. Technology, operational procedures, and the complex human factors involved all come under intense scrutiny. The echoes of these events resonate deeply for years, even decades. They actively shape the future of how we fly. Every life lost in such a tragedy fuels an unyielding determination. This determination is to prevent any recurrence, ensuring history does not repeat its sorrows. The quest for aviation safety is a truly global, collaborative endeavor. Lessons that are learned in one corner of the world provide vital benefits to all nations. International regulatory bodies work closely with aircraft manufacturers. Airlines and national aviation authorities also play crucial roles in this network. This intricate web of cooperation is absolutely vital for progress. It ensures that crucial safety enhancements are shared effectively. It also guarantees they are implemented widely across the global fleet. The skies above connect us all, as does the profound responsibility to protect every person who travels through them. This shared mission is a powerful force for continuous improvement. The remarkable evolution of air safety is a detailed story. It is a story of countless incremental improvements accumulated over time. This progress is carefully built upon many layers of learning. Each new safety regulation introduced adds a shield. Each carefully refined operational procedure strengthens defenses. Every single technological advancement provides another layer of crucial protection. This incredibly complex system is meticulously designed to be robust and resilient. However, human vigilance can never ever be allowed to waver. The deep commitment to ensuring safety must be actively renewed each and every day. It is a solemn, unbreakable promise made to all passengers who trust their lives to the skies. Section 1. The Unending Vigil. Aviation's dedication to safety. The dream of flight is a powerful one. It has connected our world in remarkable ways, yet this dream carries an inherent risk. The skies are a demanding environment. Operating complex machines at high altitudes requires constant vigilance. Aviation is a delicate balance of technology and human skill. Learning from every single incident, no matter how minor, is absolutely essential. This relentless pursuit of knowledge has become the bedrock of the entire industry. Safety is not a final destination to be reached. It is instead a continuous, unending journey. The vast sky above us demands our unwavering respect and utmost care. Aviation accidents, like the tragic story of Flight 708, are profound losses. They bring unimaginable grief to many. However, these terrible events are never entirely in vain. They serve as critical, if painful, turning points for the industry. Such incidents force a comprehensive re-evaluation of everything previously understood. Technology, operational procedures, and the complex human factors involved all come under intense scrutiny. The echoes of these events resonate deeply for years, even decades. They actively shape the future of how we fly. Every life lost in such a tragedy fuels an unyielding determination. This determination is to prevent any recurrence, ensuring history does not repeat its sorrows. The quest for aviation safety is a truly global, collaborative endeavor. Lessons that are learned in one corner of the world provide vital benefits to all nations. International regulatory bodies work closely with aircraft manufacturers. Airlines and national aviation authorities also play crucial roles in this network. This intricate web of cooperation is absolutely vital for progress. It ensures that crucial safety enhancements are shared effectively. It also guarantees they are implemented widely across the global fleet. The skies above connect us all, as does the profound responsibility to protect every person who travels through them. This shared mission is a powerful force for continuous improvement. The remarkable evolution of air safety is a detailed story. It is a story of countless incremental improvements accumulated over time. This progress is carefully built upon many layers of learning. Section 2. Flight 708's legacy, a future forged from tragedy. Flight 708 serves as a stark reminder of aviation's complexities. Its investigation revealed critical failures and a chain of events leading to disaster. The memory of those lost drives meaningful change within the industry. Improvements in air safety, training, and technology were direct outcomes. These changes ensure safer flights for millions worldwide. Honoring the past by protecting the future is aviation's solemn pledge. The sky calls to us and safety always answers.